Edison.
I'm Xuanyan.
I'm Manes.
I'm Yusin.
And our Chem AA topic is stomach woes. So gastroesophageal reflux disease, in short GERD, is a very common symptom where stomach acids flow back into a person's mouth. This results in great discomfort to people. To effectively get a solution, antacid pills are readily available over the counter in pharmacies. These antacids have different chemical components and hence will result in different effectiveness to help neutralization. So our hypothesis is that antacid containing carbonate is more effective than those containing hydroxide.
So our experiment involved making a pH color chart by testing our cabbage indicator on different solutions of varying pH. So we want to investigate the effectiveness of the different types of antacids by comparing the basicity of the different components used in it, namely carbonates and hydroxides. So firstly, to make our cabbage indicator, we added 1 cm³ of each solution of different pH to 5 cm³ of cabbage solution to obtain 5 different colors that represented the different pH. And then we used the microbit to record the light intensity of each of the solutions before plotting it on the pH graph to obtain a color chart.
Okay, so to find out the exact basicity of the acid, we dissolved 1 dose of each acid in 20 cm³ of water. Then we added 1 cm³ of each antacid solution separately into 2 different test tubes. Then we added our pH indicator, so which is our cabbage water, into the test tube. Then we observed and recorded the color change using the microbit by measuring the light intensity of each solution. Then we plotted a color chart according to our previous pH indicators of like the colors that we got of each antacid. And then we added dilute lime water drop by drop till there was no other color change to be observed. And then our experiment told that the antacid that required less drops of lime water to reach final pH was the weaker alkaline. Some safety precautions that we took included wearing safety gloves and goggles when boiling the cabbage indicator. And then we used a dropper to transfer solutions from the hot pan. And we used a cutting board when cutting the cabbage so that we minimized the injuries caused. And then some ways we prevented errors was that we turned off the lights to get a more accurate reading of the light intensity. And we used a measuring ruler to measure the distance between the light sensor and the test tube to ensure that it was the same.
Okay, so the results that we got for the different pH. At pH 3 had a light intensity of 140, while at pH 5 we had 150, and pH 7 we had 110, 8 we had 145, and 9 we have 160. So we plotted a graph according to the pH and the light intensity of the solution. I went through the thing. So we also tested the indicator with the sodium carbonate solution and the magnesium hydroxide solution, and we tested the light intensity. I went through those, and the results is that sodium carbonate we had 160, which comparing to our graph is the same as the 9 pH solution. So from that we can conclude that sodium carbonate had a final pH of about 9. While for magnesium hydroxide, we had a light intensity of 150, which comparing to the graph is the most similar to the pH of the toothpaste, which was pH 8. So you can conclude that magnesium hydroxide had a final pH of 8. So since the remaining pH of sodium carbonate is greater than that of magnesium hydroxide, you can conclude that the antacid using sodium carbonate is more effective since it is more basic.
So that's our chem investigation.
Thank you.
Thank you.
Feedback for group 4. So our first feedback is that the methods are a little long, so it could be shortened for easier understanding.
We also think that the poster is too wordy, so it can be a bit hard to read. So it would be nice if we can summarize the important points or highlight the more important points. And also, however, we thought that they had very clear explanations and they demonstrated their in-depth analysis and interpretation of the chemical data that they provided with.
So we also thought that they drew out logical conclusions and are supported by comprehensive chemical evidence first they put their chemical equations in the poster. And they also constructed and justified by providing chemical explanations, and they also provided their methodological considerations, which we thought was really good.
Lastly, there was good demonstration of ability to analyze chemical data with good understanding in chemical concepts.
Thank you.
You ensure that the opacity of the dissolved solutions doesn't affect the light intensity measure. For example, when toothpaste is introduced to water, bubbles are formed and it becomes opaque.
So for toothpaste, we use a little bit of it. So when we mix it with water, light can still pass through, so it's translucent. And also when we extracted the solution, we use the dropper slowly and carefully to ensure that there's no water bubbles.
And we also use a bit of the materials only, we use a bit of toothpaste only, and then we diluted it a lot, and so that we ensure it's transparent and the light can pass through.
How did you make the color chart that you stated in the poster?
For the color chart, we took 5 cm cube of cabbage water and placed it in one test tube. And then after that, we put 1 drop of very diluted solution inside until the color changed. And we compared this color that we have gotten with the known estimated pH of the solution with the Google image that we saw online.
So after we had all the colors, all the test tubes with different colors, we took a picture of the underflow light so that we could use it for references later on. Then we tested the light intensity of the different test tubes by using a microbit and testing how much light to go through it. And then we took the values of the light intensity and graphed it into a graph.
Thank you.